Welcome, everyone. My name is Lin, and I'm a director of data science at Wealthsimple. And yeah, today I'm going to introduce to you a creative way to perform predictive modeling. Let's dive right in. All right, so let's start with a scenario. Let's imagine you are a data scientist at a bank. You have access to credit card transaction data from 1 million customers at the bank, and you were asked by your marketing department to identify who's potentially a parent of young children in your client base. What do you do? Well, usually these days, the first reaction of the data scientist is to go ask LLM. You put the question into one of the or whatever AI hosted by your company, and then you get a response back. And actually, that's exactly what I did. I put that question into a LLM, and the answer it gave me is you can use a rule-based approach or a machine learning model. You can flag as likely parent if within the past 6 months you've made X purchases at baby child targeted merchants, or Y number of purchases at pediatricians, children's clinics. Sounds reasonable, but to do this, it actually requires you to come up with a very long list of child-related merchants. You have to actually tell the model, which merchant belongs to, baby or child targeted category, which could be a cumbersome task. In terms of ML, yeah, we could build a logistic regression or random forest to predict who's likely a parent. But to do that, you actually have to have a target. You'd actually have to know, at least within part of your database, who's is a parent. There has to be a label for that. But in reality, likely you don't have labels. So what do? Why don't we just ask LLM to do that for us directly instead of telling us to build another model? LLMs have common sense knowledge, and they can grasp, which merchants sell baby products and services, toys. What if we just treat LLMs as an analyst reading these case files? Well, that's basically the thing I did next. So, for example, here's a prompt that I gave the LLM. Here are the top merchants that client A shopped at: fancy toy stores, super baby strollers, crazy land amusement park. And I just asked the LLM, hey, is this client a parent? And the LLM gave me a pretty good answer. It says it's highly likely that the client is a parent of a young dependent children, possibly an infant or toddler, given that the stroller, there was a stroller purchase. And it actually also gave me some precautions, right? With only this data, there remains a slim possibility that the purchase is here for gifts or relatives, which is fair. But these 3 merchant choices together make that hypothesis very strong that it's a parent of a young child. So good answer, LLM. Can you do more? Basically, all now I have to do is loop through the remaining 999,000 clients in my data set and ask LLM the same question. So I essentially turn a traditional ML pipeline where I get the data, I do my feature engineering, I put it into a machine learning model and get a prediction. I change that into I just write stories based on my data, and then I just ask LLM, hey, what do you think? Do you think this person is a parent? I don't even have to give a target or label target to this model, and then LLM is going to give me that prediction. And I'm calling this flow story is all you need. Why do we have to turn the data into stories? Well, humans understand context through stories, which capture nuance, causality, timelines, and sometimes even emotions. And actually, LLMs operate largely in a similar way by turning the data, the raw data, into stories, not only does it make it easier for LLMs to understand it, it also helps it capture more nuance and timelines. All right, so let's dive into a sort of quick demo about this. Instead of predicting, who's likely a parent, let's say we have some financial data about some customers, and we want to know how likely are they gonna, default on some credit products, loans. Here I just listed 3 examples: client Alex, Jamie, Morgan. These are hypothetical clients, and I have their income information, whether they use overdraft, have they missed payments, what are their credit card balance, major events, and I write a narrative template first to turn those raw data points into stories. For example, for Alex, this template would become, in the last 3 months, Alex's income changed from 3,000 to 2,500. During this period, they had 3 overdrafts and missed 2 payments. Their current credit card balance is 7,500. And a notable event, they lost their job in month 3. And then the next thing I will need is basically to write a prompt for the LLM, given the narrative that I just wrote. So basically, I tell LLM, here's a story of the client. I paste the narrative in based on this history. How likely is this client to default on a credit card payment in the next 12 months? Please answer with a percentage probability and a 1-sentence explanation. Obviously, this is like a very simple prompt. There's a lot of room for improvement through prompt engineering. We can definitely add a lot of nuance and context into this prompt. Maybe also, give more of like a role to the LLM. Those will all help you kind of get better predictions from the LLM. But just for example purposes, here's a simple version. And, LLMs can typically give you a pretty good answer just based on stories and prompts like this. All right. How does this work in practice? So on my team, we've actually run some real world examples for this new flow. For examples, we sometimes would use this to come up with LLM generated audiences for our marketing campaigns. And what we observed is that, not only does this new flow make it much quicker to bring new audiences into market, but actually, also provides higher conversion lifts. It's actually more accurate in a lot of the predictions it makes. On average, it generated like a 40% lift in conversion rates compared to traditional marketing audiences. And there's so much room for improvement as well. And I think the opportunities are endless. Why do we think it works in practice? Well, first of all, like I mentioned, LLMs are good at handling data with external context, right? For example, merchant names. If we were to build a traditional machine learning model for this purpose, we wouldn't have to generate a huge list of merchants that we think are related to, child-related purchases, and we have to basically like build a big lookup in our machine learning model to see, which merchants belongs to this category. You don't have to do that for LLMs. It knows that through common sense, right? So that saves you a lot of time, and in many ways, it is more accurate than that traditional approach. Secondly, LLMs have common sense. It knows what parents typically buy, right? So that's very helpful, and that's also something that's hard to ingest into a traditional machine learning pipeline. And thirdly, LLMs can be treated basically as a general purpose pre-trained model. You don't always have to give it a target. It knows, the characteristics of a parent. So you don't have to have labeled data sets. And that's a big advantage in a lot of the cases. When should we use it? Obviously, it doesn't solve all the problems in this world. And the way we think about it is we should use it when the cost of making a wrong decision is relatively low. For example, marketing decisions usually have higher tolerance for errors compared to a risk decision, where you, for example, try to adjudicate people's credit risk. That's usually a much there's like a bigger consequence for making a wrong decision versus the marketing purposes. And it's very helpful when you want some rapid prototyping, right? You just want to prove, oh, like I think predictive modeling can solve a problem. Let's try it using this approach. It's quick. It needs very little setup. And then if it actually works, then maybe you can invest more time into traditional machine learning approaches, or even like a combination of the two. And thirdly, kind of similar to what I mentioned before, when you want to perform supervised learning, but you don't really have a clean target, right? You don't really know which clients in your data set is a parent, but LLMs, through its common sense, might help you identify who's a parent. And you can even, if you don't want to use, story is all you need for the entire problem, you can use it maybe to come up with, machine labeled targets to train your traditional machine learning model. That's also a very viable approach. There's obviously a lot of considerations that you have to put in before going all in into this creative approach. Data privacy is definitely one of the biggest considerations. You would have to make sure that you comply with the data privacy rules, and your company, you should consult your internal compliance teams to make sure that you're doing the right thing. You're not leaking important client information. Preferably, you should use self-hosted LLMs. You should never put private information, client information, on public LLMs. So that's definitely concern number one. Hallucination risk is obviously still a concern for LLMs these days. Sometimes it would make funny mistakes, and that's why you shouldn't use this method for use cases where like the tolerance for error is very low. You should always try to validate your LLM outputs wherever possible. You should try to make sure that your use cases can tolerate a decent amount of risk. And largely, and I guess on the cost side, this varies depending on the use case. It may be costly at times, depending on how your company uses LLMs and what kind of deal it has with LLM providers. But you should always weigh that against the faster speed to market and improved accuracy in certain cases against the cost, and see whether the use case deserves it. And lastly, I'm going to talk about implementation. So the first thing that we noticed is that LLMs are not great at counting. If you feed too many stories to it at once, it could cause it to miss some predictions, or even give funny answers on some of them. The safe way is to actually give one prompt to the LLM at once, and then loop through all the cases. But obviously that could be very slow. So you kind of you have to find the sweet spot of how many stories you should include in a batch, and basically experiment with it. And ideally, you should work with platform teams to come up with like a batch inference method that allows you to do this in a cost efficient and also like compute efficient manner. You should always try to fine tune your LLMs when possible. The examples I gave, for example, are more related to financial data. So ideally, you should use a LLM that's fine tuned towards financial data, and that usually can give you better predictions. And lastly, like I mentioned before, using a combination of traditional machine learning and this new method usually give you better results. So if you can afford it, try to do both, and that should give you better outcomes. With that, that's basically the presentation. Story is all you need. And please feel free to ask me any questions you may have.
All right, I'm going to pose a question to you, Lin. So Wealthsimple is a really great platform. It is a platform that I personally use as well, and I find it very good and easy to use. How has the safety around using LLMs for customer-facing models been, how can I say, been managed? And do you find similar challenges in the wealth management or the financial services industry, myself coming from IT banking over 10 years?
Yeah, that's a great question. We definitely put a lot of effort, investments into having self-hosted LLMs and having like a very well-governed data privacy and security measures around that platform. Myself, I don't directly manage that side of things. But every model that we bring to the market, we go through a lot of compliance and privacy checks before they reach our customers. So I trust my counterparts in the security and privacy departments to have all the right guardrails for the models. But in terms of the details, I would if you want to know more about the exact details about that those guardrails, I can help you find out from my counterparts. What does your stack and tool chain look like? Sure. So at least within Wealthsimple, we are gradually moving towards like a one row at a time type of LLM inference over to like a batch LLM inference. So like I said, we're trying to find that sweet spot, right? Like how many sort of stories which are sent to the LLM in a batch is balances the accuracy and the speed. So we're actively experimenting with that. And in terms of the tools and stack, we use Airflow, for example, to automate and schedule a lot of our batch inference jobs. And for real-time inference, we have kind of like an internal self-hosted kind of inference endpoint that's built on AWS infrastructure. So hope that answers your question. Can you maybe concrete describe how this looping through each use case work? Yes, at the beginning during the prototyping stage, we did just use a simple for loop. So each time we provide like a single prompt to the LLM and expect a single answer, and just loop through however clients we had. But yeah, we are moving towards more of like a batch way. So instead of like sending one story to the LLM, we send a batch of stories to the LLM and try to get answers in parallel.
Thanks for the presentation, Lin. I just wanted to ask a question about crafting the story. I can see a little bit of expertise in crafting the story itself. And I know that at the end of the day, the inference that comes out of it will depend on the quality of that story you've crafted. So what advice will you give to make sure that what goes into as input as regards the story itself, it's good quality, so that people don't just craft any story that will give anyhow results?
I guess like there's a balance you have to find when writing stories. You want it to be you want to feed as much information to it as possible. Meanwhile, you don't want it to be super long, so that it takes longer for LLMs to process, and also there's the more tokens you consume, the higher the cost it would be. So it's very important that you try to make it super concise. Basically raise the density of information in your stories. But like very important things are like timestamp, for example. LLMs are not great at counting. So if you're putting timestamps in your stories, usually you want to maybe help it pick differences between timestamps rather than feeding it raw timestamps, because sometimes LLMs could misinterpret some of the timestamps. So I think that's like some of the nuance that you have to work through. Basically treat LLM as a like almost like a human agent, right? You also want to like make sure that you explain super technical terms to it, and don't always expect the 100% accurate answer from it. Hope that answers your question.
Yes, it does. Thanks.
Perfect. And there's one more in the Q&A. How did you ensure the hallucination is addressed? Yeah, how are you catching? So we tried to, obviously before we made further investment into this approach, we validated this on use cases where we had some labeled data, right? So we don't feed the labels into the LLM, let LLM generate the answers, and then we compare that against our labeled targets. That's usually a good place to start, right? So like, are there mismatches? And in the cases of mismatches, you can try to see, how is the LLM thinking? And sometimes you can even ask the LLM, hey, like, what was the reasoning behind you making this decision? Because I don't think that's right. And then usually LLM can give you a pretty good answer of, oh, like, why did I make a mistake? So that's usually a good place to start before you, completely trust LLM to make the decision for you. Ensure model is not biased towards a particular group. Right. Well, obviously, like I said before, risk decisions have much lower tolerance for error. So I generally wouldn't recommend using this approach to make risk decisions. This is more just like an illustrative example. But there's obviously a standard set of fairness procedures you have to apply when you build risk-related models. And those methods still apply in this case, right? You always want to check whether your model is making biased predictions across gender, ethnicity, and those things. If you were to use this method for risk decisions, obviously you have to go through all of them still. But in general, like using this for risk is still, I think, at least within the industry that I know of, I don't think there's like in-market use cases using this approach, but definitely something we could explore and continue to push the frontier of. But yeah, there's definitely I think there's still ways to go before we can get there.